Red leather, yellow leather. Hey everybody, so what we're going to talk about today is gas pressure, and you can't have gas pressure without balloons. So let me show you what I'm going to do here. My contention is this balloon wants to be a big star. The problem is the weight of the world is crushing it down. This balloon has this problem where the world is crushing it and keeping it in place, and I'm going to prove that to you right now. I want to be a big boy. I can show you how this balloon can be so much more if the world's atmosphere weren't pushing it in place. So what I'm going to do, I have here a vacuum. This is legit just a vacuum. It just sucks air. What I'm going to do is with this, I'm going to be able to take away all the atmospheric air, and you're going to see what happens with this balloon. I'm a big boy. So as you can see, without the atmosphere pushing that balloon in place, that balloon can get as big as it wants. And in fact, this is sort of what happens when we talk about going into space and how people, when they, in movies, get outside of the spaceship, their head explodes and whatever. It's because pressure is keeping this balloon in place, and now that I've removed that air pressure, the balloon can get as big as it wants. In fact, it took up the whole container. And if I return that air pressure by releasing it right here, it goes back to its original size, because now the world has crushed it down to its size again. So basically, let's look real quick what we just did. What we had was a balloon, and you saw me put some air in there. So there was some oxygen and carbon dioxide and probably some nitrogen and such, all in there. But the problem was, on the outside of that balloon, there's air here too. We know this because we breathe every day. So there's other air in the atmosphere pushing that balloon. And right now there's a fight between the air in the balloon and the air outside the balloon, and that fight has the line of battle right there. That's where the line of battle is. When I remove some of these outside air particles, which is what I did with the vacuum, now there's no fight on the outside, more fight on the inside, and that balloon was able to get bigger, which is what we saw, that the balloon got a lot bigger. All right? The same thing will happen with water. I'm going to put water in this little jar thing. And the water in that jar wants to leave. But the problem is there's air in the atmosphere keeping it down. And so they don't get to leave the water. If I get rid of that air, the water will be able to boil. And it's going to boil at room temperature. Room temperature being the temperature of this room. What's the temperature of this room? That's why I got this cool thing. Hopefully this shows up. This is a temperature where the red dot goes is what temperature it is. You seeing that? Excellent. So as you can see, it is 17 degrees Celsius, which is 62.6 degrees Fahrenheit. That's what temperature that is right now. So I am going to put some water in this thing, just like we talked about, right? There it is. I'm gonna take some of this water. It is not hot water. The only way I can prove that to you, since you're not here, is to hold that thing on there. There we go. And it says, hopefully, the same number, about 62 degrees, which is nowhere near boiling temperature, 100 degrees at 17 degrees Celsius. Okay? And what I'm going to do, this is especially made so that it won't crack and explode in my face when I do this. I'm going to do the exact same thing I just did with the balloon, and I am going to boil this water. This water is going to start boiling because there's air pressure in there right now keeping that water in place. And when I take away that air pressure, when I remove that air pressure, that water is going to be able to leave. And as such, it'll be boiling. So here we go. Don't worry about that. That was all part of it. So as you can see, that is boiling at the same temperature that it was at before. So the water is boiling even though its temperature didn't go up. So the reason for that is because there's no more air pressure fighting it in. So as you can see, I can touch that. It's not boiling me, right? It does not hurt at all. It's as cold as it was before. So air pressure keeps water in place as a liquid. Air pressure is keeping this balloon in place so it can't get bigger. So air, gases have some mass and have a force, a pressure that makes that happen.